out of heals. He's out of heals. He's been on 20 HP this whole time.
Do I need to reboot? Will this work? All right, this works. I think I'm live now. I need to figure out a few things and then I can get started. This has been a good series of lives. All right. I think I'm ready to start. I just need to get a sweater because it's still fucking cold. And I get started. All right, be right back. All right. So today I want to take a look at this. My coworker Stefanos shared that with me. And this looks like a cool paper. Actually, my ex-coworker is involved. This is great. And after that, I guess I want to take a look at Zcash again because I can't remember exactly the basic schemes of Zcash. I want to take a look at Monero again because I can't remember how the nullifiers work and why they have nullifiers. Zther again, just to look at the Elgamal stuff that I forgot. And then, I don't know, Tachyon, Zcash, Vitalik, blog post on stealth addresses maybe. We'll see. Where can I put that? Can I change my screen? Give me a sec. All right, let's get started. I know I keep saying that, but where are my windows? All right. Okay, let's back to this and let's try and speedrun this one because I've already lost so much time. It's already 3 p.m. where I am. All right. SOK, privacy preserving transactions in blockchain. Various privacy definitions. All right, let's jump. Let's jump. I guess that's what I should have looked at. Related work. What is 26? Oh. All right, in section of privacy, systemization of different notions of privacy that can be achieved for blockchain transactions. SRX. S is a sender, recipient, amount, transaction amount. A transaction without any privacy support reveals the sender, receiver, and the transaction amount. We note that when we say that the sender, receiver of a blockchain transaction is revealed, it refers to the exposure of their address rather than their actual identity. This is pseudo-anonymity. It's here, pseudo-anonymity. So that's Bitcoin. We do not consider this approach to offer any meaningful level of privacy. I guess I never really read on what really annoys people about these kind of things. But maybe it'll be nice to read a paper at some point. What was that? I should unpin these. Starting to get hard to track everything, but let's go. This is pretty short also. So I guess that's the main problem with Bitcoin, right? Is that sometimes you want to pay someone and they have an address, and you can't ask them to create a new address every time you're paying them. They need to have a fixed address, right? If they're a shop and they have a QR code or something like that, you need to pay them. You can't ask them to create a new address every time. So you either encrypt the address, the recipient address. That's what Bitcoin does. Zcash does pretty much. Or you create a new address that looks like the same address, but is not related. That is the same address, but it looks like it's not related. So that's Monero, stealth address. Or you just don't care about revealing the recipients, and that's basically Zether. Oh, and I guess when you create change, you know, one of the output is going to be a change. So you can always track where things are going to. So that's interesting. So first thing is that people want to basically are reusing the same address. And so when you see the same public key being used several times, you can assume it's the same user. And the second thing is when you see something being spent, you can be pretty sure that one of the output is a change address. Is that all? All right, that's all. Not much. I mean, I like it. Short papers. So definitions are good because I haven't really looked at definitions so far. And it's good to, you want to simplify, you want to create an abstraction that's simple enough so that you don't need to think about other things, to think about anonymity and privacy, but you don't want your abstraction to be so dumb that you can't really reason about interesting things or you're missing out important security concepts. So confidentiality, they say it's when a transfer amount is encrypted. Key anonymity. This key anonymity is not always like that, right? Like in Monero with ring signatures, it's only on the sender side, but and on the other side, you don't really have a. I guess it's the same on the recipient because when they're going to use it, there's going to be a key anonymity here as well. So actually, that is a good way to look at ring signatures. Even though we only use it on the sender side, the receiver will eventually use it, and it'll look like that as well. So okay. Full anonymity, you don't know anything. I think it's called total anonymity in other places. Sender receiver unlinkability. So that's the coin join kind of thing. But how is the coin join different from key anonymity? Key anonymity. Okay, sender receiver unlinkability is worse, right? Because everybody in this ended up transacting. Whereas key anonymity, you don't know if these people are transacting. These could be dead addresses. You don't know the amounts. I mean, here you don't necessarily know the amounts. I mean, there's two cases, right? Sometimes you know the amounts, like in coin joins. Sometimes you don't know the amounts, like in Mimble Wimble type of coin join. And confidentiality alone is basically Zither. So unlinkability, I think that's interesting. Auditability, maybe that's something I should mention. I would call that like policies, maybe. Accountability sounds like something you have to enforce after. So stealth address, if I think about it, does it provide unlinkability? What does it provide, right? What's the difference with like someone using a new address in Bitcoin? Oh, no, that's very different. With this, you can use an address you know, so they can have a fixed address, but you don't know that they're receiving it. So it protects the recipient. Is it a recipient? How do they call it? Anonymity. It's like receiver anonymity. Or what do they say? The last time I looked at stealth address, there were 2 keys. Basically, here they use a different public key, but here they reuse the same one that he does a key exchange with. I'm not sure why in Monero they use 2 public keys instead of 1. Dual key stealth address protocol. Well, Aztec Network uses that. I don't know. I don't know if DI is gonna understand what I'm saying here. All right, they use this thing where like if you want to be audited, you use the A as like hash of the private key of B or something. I can't remember that. Oh, so you can detect, but if you know the private key of A, you can detect things, but you cannot spend because you don't know B. So like there's a service that can, okay, interesting. Okay, that's interesting. I mean, that's true. I just don't know if ChatGPT is correct here, but it seems like it's true. Maybe that's what that's what Vitalik says somewhere here. Oh, status addresses and separating spending and viewing key. Okay, interesting. Yeah, that's what Vitalik is saying. That's a lot about stealth addresses. What? Come on, bro. Okay. ChatGPT is not very happy. Am I gonna have to reboot? I hope I'm not gonna have to reboot. Also, my computer is going crazy, so maybe that's what's happening. Would Zcash work with stealth addresses? That would be interesting, no? Why wouldn't Zcash use stealth addresses? I guess just because they don't need to. They could do it, right? Those Zcash is using, like, you encrypt to public keys and that's how people get it. Instead of that, it could have like clear transactions that say, hey, I'm spending this encrypted amount with, like, by releasing this nullifier and this zero knowledge proof that this nullifier exists, and I'm sending it to this public key. And then the public key and the commitment to the value would just be inserted in the Merkle tree, right? Has anybody thought about that? Well, in Zcash, you know that output exists, right? Every time you create a commitment. Do they? Commitment also doesn't leak that. Well, I guess it seems like we could do it. I just don't understand enough about Zcash to really understand the trade-off here, or even if it's doable. But it seems that intuitively you could do it. And it would be easier than their encrypting, and I would think. Let me tweet about it. Maybe someone will know. All right, let's see if anyone is triggered by my message. Let's go back to this, right? We just wanted to go through that. Right, you encrypt the. I mean, this is Ether. I mean, is any, yeah. If you have homomorphic commitments or homomorphic encryption, then you do -x plus x. That makes sense. Oh yeah, range proofs. I need to make sure I talk about that. So I mean, I think here they're describing Zether, because I don't think in Monero you have ciphertext that corresponds to 0. Like I don't think you do any of that. This is anonymous Zether that they're describing. Oh, icon base, yeah. So Zether. And before stealth addresses, and then we're looking at UTXO base. So that's gonna be Monero, CoinJoin, all the stuff like that, right? I mean Zcash. So I guess David Shum, in David Shum stuff, you reveal the serial number. In Zcash, I mean the serial number is the coin. You reveal it. In Zcash, you don't reveal which coin you use, but you reveal the serial number inside the coin, which becomes a nullifier. Nullifier. Neat and poor. Tumblers. What is centralized tumblers? CoinJoin. Where is it? I've been thinking about this attack, which is really interesting. All right, back to the paper. I'm curious to understand how centralized tumblers work, but I obviously don't have the time to look into it. I would love to look more into coin joins and how people create all sorts of coin joins and try to make it happen in a non-interactive way or decentralized way, these kind of things. And also centralized tumblers. I guess I don't understand too much. And I guess ring signatures, I looked at it yesterday, but it was quite complex. Oh, TEs also, right? TEs would be interesting to mention. Are viewing keys always for that? So I feel like sometimes viewing keys are more for detecting transactions in these blockchains, in these privacy blockchains where you need to detect transactions and you can't just check an account. So like these I guess these are UTXO based privacy coins. Like if having a viewing key is useful, but not for auditability. Oh yeah, I remember there was this paper that used ReZero pay machine banks. I can't remember what was the. It was not a privacy stablecoin, right? It was like just to facilitate payment in Singapore, cross payment, right? What was that paper? Project Mandala. Fuck yeah. One month ago. Wow. All right. That was I glanced at it. That seemed like a very interesting report. I wish I had more time to look at that as well. But right now, I'm just getting distracted and just looking left and right when I should just focus on finishing that paper, I guess. OS Peterson commitments. They did include serial numbers at first and then they fixed that bug. All right. I mean, the CT paper added that, right? It's not from the zero cache. Curve trees and Vega, that I don't know what that is. Isn't my co-author in this one? Yeah, my co-author, my co-founder. I think I skipped a bunch of stuff, so I'm coming back. Dash. Oh, I was here. All right. Triptych. Well, there's another privacy preserving cryptocurrency called Firo. I've never heard of this one. That's insane, the number of cryptocurrencies out there that exist, I guess. All right, I know I'm getting distracted, but this is interesting. All right, I see that people are not. What exactly are we looking at right now? I'm getting distracted, so that's I don't know if that question is a diss or an actual question. We're looking at page 11. We're looking at this SOK, privacy preserving transaction in blockchains, and I want to look at Zcash and Zcash, Zether, and back to Monero really quickly after that. But I keep doing side quests. And Jan Myers, is your goal just to have multiple unlinkable? Oh, he answered to my tweet. Is your goal to have multiple unlinkable addresses with one private key? Zcash has support for that via diversified addresses. Actual stealth addresses in the dumb BTC ETH sense don't make sense. The transaction already hides who it's going to. that both sign. Mech0768 says, by using with stealth addresses, we basically create a super private shielded pool, kind of like a dream come true for unknown transactions. Okay, that sounds like a bot. Sorry, Mech0768, if you're not a bot, but that's kind of a weird answer. All right. So Fyro, that's interesting. Well, so they're doing some interesting stuff. Yeah. I wish this would go in more detail. I don't think I understand how that works, but I guess there's some shuffling to make it to get rid of the centralized party that helps with the coin join, I guess. What was the other one? The one that allows you to track if a coin was like tainted? Is it like Railgun? What's the crypto project that's privacy coin allows you to prove not tainted? I thought it was Railgun. privacy pools, I guess. Tornado Cash, I guess. I mean, shielded pool. Privacy pool. Oh shit, there's also MPC and FHE. I should mention that at some point. Anonymous Ether, all right. That looks interesting. 11. Do you know that Matteo Campanelli is so prolific there? Wait, how do I know that guy? All right, never mind. It's not a paper. All right. Google's better. Let's move that next to quiz quiz. Where's quiz quiz? we'll leave it there. We'll leave it there. That's the problem, I guess, with MPC and FHE protocols, right? You need to touch all accounts. Do you? I guess you don't need to touch all accounts. You just need to be able to have a circuit in FHE or an MPC that goes down a Merkle tree and updates the Merkle tree route. But then, wait, no, because then you don't know what you touched in the Merkle tree. You need to, you're touching all the encrypted balances, so you need to go through everything. That sounds really bad, no? Right, I never thought about that, but FHE and MPC are linear approaches, basically. That's an interesting insight, isn't it? Well, the secret network was a Cosmos-based blockchain. Okay. All right, let me get a glass of water, and I'll be back. Actually, should I finish that? We're almost at the end, and then I'll get some water. I mean, Tornado Cash is such a scheme, right? Circle introduced a confidential ERC20 framework. All right, 58 and 35. I like this. This is great to see on paper. Can we devise mechanisms to prevent replay attacks, double spamming, front running sender and receiver anonymous account-based payment schemes without limiting parties to a single transaction per epoch? Is that what anonymous Zether ended up doing? I can't remember. I thought they had a way to not do that. That one is interesting. It seems like this seems like an information theory, impossibility results. User experience. Are they going to talk about their own experience? That is interesting. 6 to 7 minutes for assurance of transaction finality. Oh yeah, but that's just Bitcoin stuff, right? Monero usual. Also, Pharaoh was called Zcoin. Okay. All right. All right. I'm gonna get some water and then I'll be back for. I'll be back for. Let's look at the Zcash. Very quickly, let's look at the Zcash paper, the intuitions. All right, BRB. All right, Zcash. So you're just committing to a serial number with some opening blinding factor R, and that serial number is a random value. What is CM list? Right, the Merkle tree. All right. I mean, that's yeah. So we use a Merkle tree. Step 2. ST99 was was ST99? Was it like encryption of coins on top of David Shom coins? Don't remember. Yeah, step 2 is just use a Merkle tree. Step 3. Yeah, when you create a coin and send it to someone, you can still spend it because you know the serial number. And you can see when it's being spent also, I guess. So the naive way is to immediately spend the coin you just received to hide it. This is David Shom, same issue with David Shom stuff. But I believe the fix for David Shom's coin shouldn't be too hard. So there's a non-fungibility issue, right? Isn't the second prime and the third prime the same? I don't understand how the PRF of SK gives you a public key. This is not a public key cryptography, right? I guess this is just not public key cryptography. I guess the PRF is the thing you're gonna have to prove, and APK is the thing you put in a commitment to say this commitment can only be spent by whoever can prove this PRF from a seed ASK. Wait, what is random R? So you're deterministically generating the blinding factor and the serial number is S serial number? No, the serial number is here. So you deterministically generate the serial number. And so you'll, instead of just having the serial number there, you'll have to prove that you can derive the serial number from the. They don't really explain why you cannot just have the serial number here, right? I know this was the fairy gold bug, but is that what they're fixing here, or are they trying to talk about something else? Wait, wait, what is? Okay, okay. So you first commit to these things in K, and then you commit to K with the value in this one. I don't know why there's two layers. I guess because when you want to send something to someone, you'll do V and K, and you won't know what K is. I don't know. No, you know what? You know what K is because that's the. Wait, who's the recipient's public key? I'm confused. Hey, what is S again? This is a very confusing explanation. So I don't know why there's a. Oh, S is the opening here. So I don't understand why this is a commitment if you're gonna reveal the commitment right away. Maybe you're just doing that so that the validators, the network doesn't have to do it. So yeah, you do use the public key here from the person you're trying to send, and it's a very different from the one here. So this is confusing. So here you use it for these other people. So in a transaction, you don't see who you're sending to. Oh shit! But the value is here. What? Oh, I mean, it's a mean transaction, right? You're trying to send to yourself. You're trying to go from the outside wall to the shielded pool. Okay, that's what. I wish there was some structure here. So let's look at the new transaction. Yes, it's a bit below transaction poor, but that's to go back to the real world. I don't know. So this time you don't know. You just probably have a ZK proof that this is computed correctly, right? Right. So you're producing a ZK snark for the following statements. Wait, what is this poor? Mint and poor? Let me ask here. So we're not to the sending coin. So we are Going back to the transparent stuff. Spend shielded coins and create new shielded coins. What? Then what's the sending coin stuff? All right, okay, let's finish. So what is RT? What is RT in? I don't understand why they call it transaction poor. What does it mean? Oh, the root Merkle tree, right? So you use that root Merkle tree to spend that serial number. You have a proof that tells you that you computed the serial number correctly from your private key and some value that was in the commitments. That commitment killed exists in the Merkle tree, right? Oh, that's not in the Merkle tree. Killed is here, and CM old is in the Merkle tree. The coin commitment CM old appears as a leaf of a Merkle tree with root RT, right? CM old is a commitment to the value. So we're gonna need to check that the value correctly splits here. Don't know if we have to do a range proof of these guys. Seems like you might have to do a range proofs here, no? What? Hey, that's a range proof, no? It's so funny because I was looking at this with Matthias, my co-founder, a very long time ago, and we're looking at Zcash, and I was like, I think Zcash needs a range proof. And at the time, I had no idea what a range proof was. I was like, all right. No, I understand what he meant. Yeah, but that's a range proof, right? Okay. So we're going to trust that there's a range proof. But it's part of the circuit, but who cares? So in K, I'm wondering why K is part of is another commitment. Wait, how do we create the commitments, the new commitments? Maybe let's look at that. And similarly for it doesn't talk about CM1 new. Oh, it's here, right? Wait, what is C old? Where is C old used? Is C old just a concept? Oh, it's just a tuple, right? So it's just it is a concept. And you need to send that to the recipient, do you? Right. So so we don't know these two values. I mean, I guess we need to know V also. The opening is C. Is that the opening of the commitment here? And we need R. R is here. Right. We can send this out of Ben, but we're gonna want to encrypt in Ben if I remember correctly. I don't know what key private encryption scheme is. That's like a fancy name for something that we already know. So you just encrypt it. You have to scan the blockchain, yeah. Wait, before I go back there, let me just go back here. The coins are well formed, sure. The address secret key matches the public key. You know the private key, at least for the one you're spending. The seal number is computed correctly, right? The coin commitment appears in a leaf or a Merkle tree was okay. And this one, we're gonna add it publicly to the Merkle tree. The values add up. All right. That's not very interesting. Yeah, you just want to authenticate the public portion, I guess. So that was just 0 coin. Is that what I just read, or like what did I just read? Oh, this is their construction. And they did build it for Bitcoin initially. So why is there this section now? 0 cash. They're just instantiating stuff? Is that what okay, I don't think that's gonna be interesting for me. It's just instantiation of what we just talked about. I love this kind of overview section because it means I don't need to read the rest of the paper. This is amazing. Is there more 0 cash paper? Oh my god, what did I just do? I'm guessing that's gonna be the same stuff. I don't know the 0 coin, 0 cash difference. What's the difference between 0 coin and 0 cash? Maybe that paper will be better at showcasing this. All right, let's look at Zether next. Just gonna do a quick tour to re-understand the LGML part, which I slightly forgot in spite of spending a month looking at it in Solana. But in Solana, they use this twisted LGML encryption, which is a bit different. It looks like a Pedersen commitment. Oh, I didn't wait. Reveals everything. Very interesting. So I guess he was pretty limited, the 0 coin stuff. All right, I just need to. I don't understand what they're saying here. All right, you cannot open these things. Right. So for person commitments, they're like perfectly hiding, I guess. Are they? No, they're not perfectly hiding, right? They're not perfectly hiding because there's one solution that, like, if you had a super computer, you would find it. So it's like computationally or statistically hiding. Right? Like a one-time pad is perfectly hiding in a way. So here you want the recipient to be able to encrypt things. Yeah, this is kind of weird because I don't think there's this prime is actually relevant. Yeah, so this so I guess whenever you have encrypted balances and your encrypted balances, or at least when you encrypt a balance to someone, what you're going to do is this. You're going to create an ephemeral public key with this ephemeral private key. You're going to do a key exchange. So YR is the shared secret, right? You take the public key of the person you're trying to encrypt to and you raise it to R. They can do the same by taking your public key here and raising it to their private key, X, to obtain the same stuff. And then multiply to G to the B. That's your encryption. So if I receive that, I can just do a key exchange to remove this part, and I'm left with this. But this is the problem with additively homomorphic LGML is that you have to brute force to decrypt. So not brute force, but it's sort of brute force. They say brute force technically is solve a discrete log, which is not necessarily done by brute forcing, but this kind of polar row, baby step, giant step algorithms, these kind of things. So if you multiply two encrypted balances to the same public key, it does add the balances. And the public key, this ephemeral public key you did a key exchange with, is you can aggregate them, right? Everything aggregates pretty well, but you need zero knowledge proof for range proofs and all of this good stuff. All right. So that was easy. All right, I wanted to look at Monero nullifiers, and then I'll take a break. Key image. So I guess this is kind of a property of their ML SAG, their multisig thing. Why are we trying to spend twice? We see the commitments being spent, right? So we already know that we already know that we're not gonna spend them again. Or you also include other people commitments as decoy. I did not. Wait, what? But then how can you do this? How can you compute this then? I'm back to being confused. So if they're the real ones, we know which ones have been used, no? Didn't it just contradict itself? Critical bug. Am I reading this correctly? Creation of unlimited number of coins. Oh, you gotta love these bugs. Never been exploited. All right. I love that. Basically, at this point, all like, I do you know any privacy coin that hasn't had a bug that allowed unlimited minting? So is there a rule that says that can you detect when a cryptocurrency, a private coin, has an unlimited minting bug that is being exploited? You would think, what is the symptom of a privacy coin being minted via bug? The symptom would be that someone is minting or rather, before the symptom, right? Someone is minting a lot of coins, then they would try to sell these coins, right? And so what basically they're doing is they're diluting the market cap, this invisible market cap, by the way. Sorry, no. Yes. Yeah, they're diluting the market cap. And so by diluting the market cap, you would think it would tank the price of the coin. So basically look at the privacy coin that are losing the most amount of money, and then you might have a minting bug there. That might be a sign that there's a minting bug. Whereas a privacy coin that is very stable or going up in price shows that there is no minting bug, right? That's a funny heuristic. I just tweeted, just learned about Monero minting bug in 2017. I guess at this point, what privacy coin has not had a minting bug? Maybe a good way to detect ones that have active exploits is to see that the price keeps decreasing, supply keeps getting diluted. Whenever I tweet stuff like that, I'm like, okay, am I going to piss off someone? I hope not. Small subgroup attack? Don't know. I'm still confused. I'm still confused. Which row of the ring? What does that mean? So this is interesting. I guess I did not understand that earlier, but because public key is always associated with some coins or a coin, when you include other public keys in your ring signature, you need to include commitments as well. And you'll have multiple such set of equations where I don't know why this one is A. Oh, this one is the real one, I guess. Everything else is a decoy, right? And then you're using the same outputs every time. So you know these outputs are real for specific addresses. You just don't know which inputs, these ones or these ones from these public keys or these ones from these public keys. Is that what's happening? Something like that. All right, I need a break. I need a fucking break. I reached 2 hours. Thank you for watching me read papers. As usual, a pleasure. I don't know if anybody's watching me because nobody's saying anything. But you know, this is fun. I enjoy being watched. And probably we'll stream again later. I still have a bunch of stuff I need to read through, and you know, why not stream as I'm doing this? All right. How do I quit this thing?